All right, so let's begin. We'll jump right into it. So here's our instructions. I'll explain why they are written that way in a moment. But here's our first example. So I'll wait for you guys to finish writing. Now, you guys, what we're doing today is we're finding the missing angle. Yesterday we did the opposite. I gave you the angle and you found the ratio, right? Today I'm giving you the ratio and asking for the angle. So we're solving for a variable here, in other words, which means that we're solving an equation. Now, whenever you're solving trig equations, they kind of need to tell you what interval to look at, because as you guys know, whatever angle gives you radical 2 over 2, there's a coterminal for that, right? That'll give you that as well, and another one, and another one. There's an infinite number of them, right? And so what they're telling you here is that we want to make sure that the answers we get are just between 0 and 360, okay? And that's all we're going to be looking at for these lessons, is just 0 to 360. We'll expand our selection later on. But for now, let's go ahead and solve this. So to solve these, you kind of have to ask yourself, what does the sign represent? So what does sign represent, you guys? Sign represents y. So we're asking ourselves, where on the unit circle does y equal negative radical 2 over 2? So when you see that sine of theta equals negative radical 2 over 2, you have to remember, okay, sine is the y value. So that means what y value gives me that? Or where on the unit circle does y equal that? So in other words, what angle? So at this point, I'm going to go ahead and switch over here to my unit circle. And let's look where the y's are negative radical 2 over 2. Now there's a lot of numbers up here. Y is negative, right? Now y is negative on the bottom half of our circle, right? So I know I don't even need to bother looking up here because my y value is negative. I know it's going to be somewhere down here. And y is negative radical 2 over 2 right here, correct? And also right there. So there's two answers. Our problems today could have one answer, two answer, or possibly no answers. Okay, in this case we have two. So let's go ahead and go back and we'll write our answers. So it's not really a matter of figuring out the answer by calculating it. It's really just about a matter of remembering your unit circle once again, where those pieces are at. Okay, so if sine is equal to negative radical 2 over 2, that means y is negative radical 2 over 2, and the angle that gives me those y values is theta equals 315 to 225. Okay, let's do another one.
Wait, so you just
You go to the unit circle. They're still circled there. Those are the two places where the y value is negative radical 2 over 2, and the angles that, because we're looking for the angle, right? The angles that go with that are 225 and 315. So you just look at your unit circle basically to find the angle that goes with those values. All right, so let's do another one. Let's do cosine of theta is equal to a half. Cosine of theta is equal to a half. All right, so cosine is the what value? It's the x value. So we're asking ourselves here, where, and maybe I should be more specific here. What angle on the unit circle has x equaling a half? So let's go ahead and look at our unit circle here. Now x is a half. It's a positive number, right? X is positive on the right side, isn't it? So I know it's got to be somewhere over there. Now remember, there could be 1, 2, or none. Now if there's 2, it's because of the symmetry, right? So let's go ahead and see what we can find. You guys see where x is a half?
Yeah, 60.
Right there, right? So one of our answers is 60. Now let's use some symmetry. Where's the other one at?
300.
Right down here, right? So if you use your symmetry, you can find the other one. All right. So the answers are 60 and 300.
So on the test, for this lesson, will you be on the triangle circle, or how do you?
Well, yes, I'm going to allow you to do that. So let's go ahead and continue on here. Let's do another one. Now this is different. Tangent is a little bit different. So I'm going to give you an example with tangent right now. Say I told you that tangent is equal to radical 3 over 3. Okay, so here's the deal with tangent. Now if I asked you what's tangent, you should tell me y over x, which you would be right. But that's not helpful for solving the equation. The reason I want you guys to memorize your tangent values and the reason why I had you fill out that extra circle on your handout for unit circles yesterday is because of this question and ones like it. So what you're going to do is you're going to look at where on the tangent circle, do we have radical 3 over 3. So let's go ahead and take a look at our tangent circle. This is mine. I just got this off the internet today. So do you guys see the radical 3 over 3? It's right there. Now you guys don't have your degrees labeled on there, and maybe later if you can just compare it to the one above it if you want. But on your tangent circle, you don't have that 30 there, but that's our answer. Where else is there a radical 3 over 3? 210. And just so you guys know, with tangent, the two answers will always be directly diagonal from each other, just like that. Okay. All right, so the answers are 30 and 210. So that's how you do it. Let me put down my answer if I can. Oh, I see. I can't get it. All right. So theta was equal to 30 and 210 degrees. So if you're given a sine, you're looking for the y values. If you're given a cosine, you're looking for the x values. If you're given a tangent, you're going to look at your tangent graph. Okay? So let me go ahead and throw a couple at you guys here for a minute here. Let's say I give you guys cosine of theta is equal to negative radical 3 over 2. Sine of theta is equal to 1. Well, maybe not yet. Sine is equal to 1/2. And then tangent of theta is equal to negative 1. All right, so go for it. Now, here's how I do it, just to kind of show you guys so that, you know, for those guys that are ready for this, you can do it too. Because the goal here is I had you memorize unit circle because you really need to be able to see that in your head so you could pull those numbers without having to look at it. So I just remember that that's a big number and that's a small number. So radical 3 over 2 is bigger than 1/2. So cosine is an x. So what I see in my head then is I'm thinking of x. Now it's a big x. It's negative radical 3 over 2 and it's negative. So it's going to be left and it's going to be very far to the left. Okay? Now here's negative 1, so it's not that, but that's far to the left. Now we know we have another point up here, right? But that's not very far to the left, right? It's higher, but I'm looking at x right now, left and right. So you know how we have our unit circle, right? I see a few crinkled eyebrows, so I'm going to try to explain this better. But we're looking at the left side of our graph, right? This point is not very far to the left. This one's right in the middle of going to the left, and this one's farther to the left, and then this is negative 1, right? Well, this is a big number, so I see it's the number that's far to the left, but not quite negative 1, so it's this one. But I also know from the symmetry, there's one right underneath of it that's also the same distance to the left. So those, now It's easier for me to do that in my head than what I just explained, but there it is. I just see that number and think, okay, far to the left, it's those 2 points, and I have those angles memorized, and so that would be 150 and 210. Now here, this is a y value. Now, what we want to look at for y values is it's not very high up, right? And remember, radical 3 over 2 is the big one, half is the small one. So what this means is that the y value is not very big. It's not very high up. We have 2 points that are not very high up. They're here and here. We have another ones that are halfway high up, and then other ones here that are really high up, and then we have 1. But the 2 that are not very high up are here and here. Okay, and so once again, I've memorized my angles, so I know that that's 30 and 150. Okay? Tangent, I look at the sign first, and I think, okay, it's negative, so I know we're in quadrant 2 or 4. And it's 1, so I know it's the middle. So I see my circle now. We're in quadrants 2 and 4 in the middle, here and here, so that's going to be 135 and 315. So, yeah, what's up, Kev?
I also got 210.
210 is here, which is good. That is a y value of a half, but it's a negative half. It's under the x-axis, right? So if you don't have that, now if you guys you really probably, like, I had you guys write yours out, but what I really encourage you guys to do at some point is to check your own work, like if you printed one out. I would at least double check all your answers online. Just type in unit circle, Google it, look up an image, check your answers, because you know, maybe I went too fast and you copied something down, or maybe I wrote something. So double check your answers, okay? That's important, because you don't want to spend all this time memorizing wrong stuff. All right, so there's that. Let's go ahead and proceed on to another type. We're going to look at weird ones now. Okay, so let's do this. Cosine of theta is equal to 1. And what's another weird one? Sine of theta is equal to 2. Well, actually, let me change this. 2 radical 3 over 3. I'll do that. Okay. Well, cosine of theta equals 1. So I'm asking myself, where does x equal 1? That means what point is all the way at the right? You could say 0 or 360, right? I think on the instructions before I erased it said 360 wasn't included. So we'll just say 0. You wouldn't be wrong to say 0 and 360, but I think the instructions I wrote down said theta has to be less than or equal to 0 and less than 360. So we're not including. So we'll just say 0 there. This one. This is a y value, right? So where does the y value equal 2 radical 3 over 3? It doesn't. That's no solution. We don't have that. Now, I don't want you guys to think, though, to yourselves that, oh, so if I don't see it on my unit circle, there's no solution. Because that's not true. Okay? You don't need to write this. But this, for instance, 0.7, that has an answer. Okay? So how are we going to know when we're looking at a weird one that's not on our unit circle and it doesn't have an answer versus a weird one but actually does? And here's how you can know. This next part I do want you to write. Both sine and cosine. In case you haven't noticed, like if you take radical 3 over 2, that's one of our numbers, right? If you actually do that as a decimal, it's 0.866. Radical 2 over 2, that's 0.707. They're never bigger than 1. They always have to be 1 or negative 1 between those two values. Sine and cosine have to be between -1 and 1. Now, 2 radical 3 over 3. I don't know what that is, but I know it's too big. So 2 times square root of 3. It's got to be between, sine and cosine have to be between 1 and -1. Now, I said sine and cosine, right? Did I say tangent? Did I say secant? I just said sine and cosine. So sine and cosine have to be between 1 and -1. This one, for instance, is actually 1.155. So that's too big. It's not possible. Okay? Sine and cosine have to be between 1 and -1. And that kind of goes back to what we learned to geometry a little bit. You guys remember how, like for instance, x is the leg and y is the other leg, right? What's my hypotenuse? 1. It's always 1, right? And on a right triangle, what has to be the biggest side? A hypotenuse. So it's impossible for the x or y to ever be bigger than 1. Otherwise, you don't have a right triangle anymore. So x and y, which are my sine and cosine, have to be less than or equal to 1. So those are weird ones to watch out for. I'm going to give you guys 2 to see if you can figure out what's weird. So what's weird about the first one is that there's only one answer. Okay? And what's weird about the second one is that there is no answer. So let's take a look at, see if you guys can find what's weird about these. I'll just give you a few seconds to cards today. All right, go ahead, Danielle. What'd you get? 270 for the first one. Let's see why. Because sine is y, right? So where does y equal -1? There's only one place where it equals -1. It's at 270 degrees. So there you go. That's weird because there's one answer. What's the next one there, Alyssa? That's our no solution. And why is it no solution? It's bigger than 1, and because this is cosine, right? Now, tangent can equal 2, just so you guys know, but cosine and sine cannot.
For the first one, it can be 3 pi over 2 and 270.
Yeah, so they're asking, can you use radians or degrees? You could use either one for now, it's fine. Now, what were you saying? So, we have a question, how is it that tangent can equal 2? Well, let's go back to that triangle thing that we did earlier. Let's do this one. Well, actually, you know what? Let's make it a little bit easier. Let's look at our tangent graph. If you have your calculators, take out your calculators and find the square root of 3. What does that equal? .73, right? And that's bigger than 1. Tangent can be anything bigger than, it can be bigger than 1.
Okay.
So tangent's just different than sine and cosine. Now the reason why I think it's better to think why can sine and cosine have to be less than 1 is because of that triangle hypotenuse thing I told you about. But that's not how tangent works. Tangent is not the legs of a right triangle. It's a ratio of the legs. All right. Let's go ahead and move on to the final bit for our day today. This one requires a little bit more math. Example 3. Now, for these, I'm going to put, when working with secant, cosecant, or cotangent, we have to do reciprocals. And I'll show you what I mean by that. I don't know if I'm spelling reciprocals right. Reciprocal. Not sure if it's an O or not. All right. When working with secant, cosecant, or cotangent, notice we haven't done any of those today? Yeah. So anytime we're doing those, our unit circle, we don't have those values on there, and that's just too much to memorize at that point. We've already got too much to memorize, right? So we're not memorizing our secant, cosecant, and cotangent values. So what we're going to do is we're going to convert them into the ones we do know. Okay? We're going to convert secant into cosine, right? We're going to convert, let's write that down. Cosine is the reciprocal of secant, okay? Sine is the reciprocal of cosecant, and tangent is the reciprocal of cotangent. So you guys remember how we talked about when we introduced those trig ratios to you? They're just the reverse, right? They're flipped over. So that's how we're going to convert these to the ones that we want. We're just going to take the reciprocal. So I'll show you what I mean. Let's do an example. Number one. Suppose I told you guys that secant of theta equals 2. Now, that's bigger than 1, right? But that's not a problem for secant. That's a problem for cosine and sine. So for secant, he can be greater than 1. Now, what we're going to do is, since we're working with secant, is we're going to convert it. And here's how you convert it. We're going to start by doing the reciprocal on both sides. Okay? So put these over 1 and flip them over. Whatever you do to one side, you do to the other. That's a legal math move there. Now, why would I do that? Well, check this out. This is the reciprocal of secant, right? What is the reciprocal of secant?
Sine. I mean, secant. The other one. Cosine.
Cosine is reciprocal of secant. So I can replace this with cosine. So since cosine is the reciprocal of secant, I can replace the reciprocal of secant with cosine. And now we would just solve it like we normally would. So we would ask ourselves, where does cosine equal a half? And that would happen at 60 degrees and also at 300 degrees. So anytime you're doing secant, cosecant, or cotangent, you're going to do the reciprocals. Let's do another one here. Number 2. Let's do cosecant of theta is equal to 2 radical 3 over 3. Now we saw that number earlier today, right? It was a weird number. It was like 1 point something. I don't remember now. Well, that's okay though for cosecant. That's not okay for sine and cosine, but it's okay for cosecant. So what's the first thing I'm going to do? Reciprocal. Now, I'm going to replace cosecant with what?
Sine.
Good. Now, before I go any further, there is something else I need to do here. What else? You guys see it? We don't like radicals on the bottom. So let's rationalize. A little bit of extra work on this one. The top becomes 3 radical 3. The bottom becomes 2 times what? 3. And what happens here? Which means I have this. And that is on my unit circle, isn't it? Sine of theta is equal to radical 3 over 2. And that's on my unit circle. Sine theta equals radical 3 over 2 at 60 and 120. Let's do one more. Let's do tangent of theta. No, sorry about that. I don't want to do tangent. We want to do cotangent. Cotangent of theta is equal to 0. All right. So what do I do first? Reciprocal. So think of these as over 1, right? So this becomes 1 over cotangent theta, and this becomes 1 over 0. Now, what is 1 over cotangent? The reciprocal of cotangent is tangent. And what's 1 over 0? So look at your unit circle. Where is tangent undefined? So that means that where tangent is undefined, cotangent equals 0. Okay, so I'm going to throw some student practice at you. I don't know if we have 2 minutes of class, but in case you want to practice real quick before we go, I'll throw a couple at you here, just so you can practice these a little bit. So let's say I gave you guys that cotangent of theta is equal to radical 3, and secant of theta is equal to oh, we don't have 2 minutes. I thought I got out 108. All right.